A more formal introduction. Mark Manary is currently the Helene Robertson Professor of Pediatrics at Washington University in St. Louis, and he has spent decades working in the area of childhood malnutrition. He also serves as a senior lecturer in pediatrics in Blantyre, Malawi, at the Medical College of Malawi, and as I said, has worked in Africa for over 20 years. He received the 2007 World of Children Health Award, as well as the Distinguished Award of the Academic Humanitarian Physician of the Year from AMA, for the American Associated Medical Colleges. And he graduated from MIT and then Washington University School of Medicine. So again, he's going to talk to us a little bit about where we are in the world of malnutrition and share some insights of his experience and work. So thanks so much, Mark.
All right, good. Thanks so much, Judd, for the kind introduction and the chance to speak with you. So this is a little bit informal. I'll tell you a little bit about myself, and I sort of have three different segments to the talk, and we might not get to the third one, which is sort of about success in the past, current issue that's really important, but we're not yet making tremendous progress with, and really what we're facing in the next 20 or 30 years in terms of nutrition and food security. So to know a little bit about my approach, I'm an engineer by training, so I want to solve problems, and I want to solve problems more than I want to understand knowledge, kind of thing. So I'm more about how do we fix this, and I'm also a person who is willing to venture to any extent that I can imagine to solve these problems. So I'm equally comfortable sitting in the WHO as one of their 5 world experts on treating malnutrition and writing policy, or going to the laboratory and discovering a new mRNA assay. And I do that all as I enter the scene as a clinician, a person committed to making the world a better place for other people. And then how are we going to do that? What kind of needs are coming up? And I'm not sure what, I was blown away by the size of your global health program here. There's no such thing at that where I work. But when I say I'm from Washington University, they pay me, and they tell me my job is 11 months a year Africa. So I'm much less common to see me in St. Louis than somewhere else. So I want to start out here by telling about a story that's a very mature story, and I think it should. Why I share it is because I think it speaks to what possibly can be done. Okay. Well, Africa, you probably all know about it. I don't really see a pointer here. I want to talk about Malawi down here. It's a country of 85%, and this is current still, so it's more of an anomaly. 85% subsistence farmers. People that live in mud huts with grass roofs, people that don't spend money every day, people that have everything they need with the work of their own hands. I'm sure everyone's been camping here in the Northwest. Life is like camping for these people. When you camp, you don't spend a lot of time in your tent. You might sleep in your tent. You might store things in your tent, but it's not how you spend most of your time outside. You get water from a common public source. This is a borehole, which is clean. Most people, honestly, have been about as far as they can walk in their lifetime, so it's usually about 20 miles, moving around these footpaths here in a Land Rover is one of our activities, how we distribute our project. And this is a terrible photographic quality, but it really speaks to why there's malnutrition in the world, why there's clinical acute malnutrition. So these ladies are responsible for every aspect of food production in their extended family. They're the farmers. They need to weed and nurture the crops. They harvest them. They store them in these structures that are they're behind there. And when it's time to cook, they take them outside and beat it into a flour on a rock, okay? Entirely hardworking and independent, more so than I've ever seen in any other society. Average people. And I've come to understand a while back, having been in Africa now 31 years, is that independence means vulnerability. Because if you can't deliver on it, then your family's going to go hungry. And that's why there's 80% of the malnutrition in this world is about that. It's not about wars. It's not about vast kinds of injustice or climactic crises or things like that. It's just simply that this family is unlucky this year. Her sister with AIDS came to live with her and had to take care of more people than they thought. Some kind of pest locally destroyed their family field, and they don't have enough to eat. It's about poverty. It's not about ignorance. And you can see healthcare's given outside there. And here's some pictures of severe and moderate malnutrition. So marasmus. This child has kwashiorkor, which is still very common where we work. This kid has swelling. If you could hear this child would be moaning incessantly, sort of giving voice to their misery. And you can see their skin breaking down here. The most important part of our immune system is being compromised with the lack of macro and micronutrients in this. So another aspect of me is I tend to want to work on the problems that I would perceive as most important, rather than problems that I think I know how to fix or help. So I think you have a chance to make a bigger impact if you go after the real problem, the big problem that people are having. And so when I first moved to Africa in '85, I have to say where I worked, those contexts, malnutrition was not number one. But I moved to Malawi in '94. My family and I lived there a couple of years, and we've been associated with that place ever since. It was. So I took a look, so I said, yep, that problem's for me. That's what I'll work on when I'm here in the Department of Pediatrics. And this is what was happening with that problem at that time. So you see the hospital here. The hospital looks like the home. Most of care is conducted outside. And these children and their mothers, these severely malnourished children, were asked to stay at this hospital for several weeks and drink milk-based foods. And there was nothing about what was being done or recommended that wasn't in alignment with the international agreements. Okay, this wasn't just a terribly poor and substandard place, and that's why there was so much problems with that. And mothers love their children very much around the world, and when they could see, they knew that they'd to be scared when the child got edema, and they would seek help and so forth. And here we are at the very best hospital in the country in the mid-1990s, and so I worked very hard, starting when I moved there in '94, to make these inpatient care facilities work. Okay, we developed all kinds of local foods that met the right nutrient requirements. We did training. We provided salts and micronutrients, standard management protocols. Worked at about 40 different places. And this is what would happen when something was really working well. There's lots of education and encouragement given at the nutritional rehabilitation units. And unfortunately, since this isn't about ignorance, this wasn't a very effective strategy. They gave supplemental blended flours, and about 10% of the children would die, and a quarter of them would go on to recover. Okay, and the rest remained malnourished in some sort of sense. So when things work well, following the WHO protocols in the mid-1990s, at real live hospitals, not some kind of Doctors Without Borders exogenous place that's thrown up where European standards are imported, this is what you got, which is pretty unsatisfying. It took me about 7 years to kind of get lots of places to that point, but I was curious and interested in what we could do at home. Could home-based therapy be a viable option? So I did a trial in 2001. Actually, in '99, I lived in a village for 10 weeks. And I said, listen, if we're going to do home-based therapy, it's going to have to be something that doesn't need to be cooked, no firewood necessary, because people were talking about feeding these children 7 times a day. And people don't have the time or the resources to find firewood and build fires 7 times a day. That it's going to have to be something that bacteria can't grow in, so it's going to have to be one of these low water content foods. It's going to have to see something full of fat and protein, and something that's not going to spoil in the tropics, okay? So peanut butter is that kind of food, and as an American, I thought about that. I had some conversations with a guy in France, Andre Briand, by email, in an era when email was a lot less common. And we came up with a trial that we were going to do in 2001. So we said, nobody gets to stay in the hospital. This was the second picture of the kids sitting around on mats. Whenever you come, you have to go home the next day or whatever. You get to go home that day. And you're going to get one of three different kinds of treatments at home. You're going to get ample amounts of corn and soy. So suddenly you're returning to a home with no food insecurity. Or you're going to get this peanut butter supplement with all the micronutrients you'd need in a day, which is about a third of the energy. You're going to get this therapeutic food that has everything you need in it, which is about 3 times the amount of the peanut butter stuff. So we worked with about 450, 60 kids that year. And this is just a graph, which recovery is on the y-axis and time is on the x-axis. And remember, what we were typically getting when a treatment facility was working really well was 25% recovery. And we could see sometimes up to 45% recovery. But I was convinced there was a ceiling there lower than half. So you see here, whatever they got at home, they seemed to do better. You don't need to be a statistician to pick up on this. And but when they got the ready-to-use therapeutic food, they were getting 95% recovery. So this was quite caught our attention, and we went on to the first year. My colleague Andre had some of this food made up in France, and it was sent to me. You can see it there in those foil packages. And then you say, well, time out, doctor. I mean, you've used an atomic bomb food, and kids got better, but you haven't done anything about their real problem. Don't they just go home and get malnourished again? Well, they don't. Here I'm telling you that those 150 kids, 12 months later, 96% were still well nourished. And that's because this problem that they have at their house isn't enduring. It's not, it's not, I mean, the food shortage they encountered because elephants stepped on their field that year doesn't mean that's going to happen next year. Or maybe their sister with AIDS has got, another way to be cared for or something. Or they have some extra assistance in on that. So, and this problem of severe acute malnutrition is a problem of 1 to 3-year-olds. We don't usually see it in younger than that. Usually breastfeeding, these are populations that breastfeed ubiquitously. And without a chronic illness in place. And we don't really see that in older children either. And when I lived in that village in '99, I can tell you why, because older people forage. 4-year-olds and 6-year-olds hang around with other 4-year-olds and 6-year-olds and go from house to house at mealtime and get a little bit of food. That kind of thing. So this was quite successful from our point of view in 2001. We immediately started making a product in Malawi, just in a mixer in a room in the hospital. And of course, we put heavily encased the whole room in chicken wire to cut down on the rodents that would be in there. And we took care of about 250 kids, and we got about exactly the same recovery rate, whether we brought the food from France or made it locally with local ingredients. And this number is not 95 because it includes some HIV-positive people in an era before ART, and food doesn't necessarily make their problem get better. And you can see these children eating local RUTF there. And so in 2003 was a famine year, and we were ready for a larger trial of this very promising treatment for malnutrition. So a famine year means there's lots of European nurses and lots of imported foodstuffs coming into the country. And the lady with the green dress that you saw there, she's got a European nurse working at her side and a lot more resources around. And so we said, let's go head to head with this upgraded treatment system for malnutrition and see what mothers feeding their own children peanut butter food at home can result in. Now, this can't be a randomized trial by subject because nobody in the right mind is going to agree to stay at the hospital or go home. They're always going to choose to go home. So we did a stepped wedge design. So in other words, we had 8 centers, and we converted one every 3 weeks from standard therapy to home-based therapy. And here's what we get there. So again, recoveries on the y-axis. Mothers feeding their own children peanut butter food were getting about 80% recovery, and the best the international community was getting was 46% recovery. Now, this was enough information for myself and some of my colleagues working with me, Andre in particular, to say, how are we going to move this from research to operation? But at the time, the international community was saying, careless, reckless, dangerous, killing children. Why would you ever keep people out of the hospital who were so sick? Okay, so in order to kind of cross that divide, to try to make that, we knew that we'd be able to do as many trials as we wanted. We were very good about doing these trials. But if we couldn't personally touch those children, how can we make this advance in therapy available to them? And here's, probably you've all figured this out, but one of the big reasons why the food works has nothing to do with the food. It's where it's given. So you see the gray bars are fever, cough, and diarrhea at home. The black bars are fever, cough, and diarrhea in the hospital. And when you are in a small room with lots of other people, who some of them have, and you're vulnerable to pathogen transmission, you're going to spend some of your time being infected and not recovering. Okay. So it's about the food, yes, but it's also about the setting that they're being treated in. So Andre and I said we're going to need to do three things in order to make this a reality for more kids. We're going to need to, change policy, so stop people from saying this is careless and reckless and start saying it's the right thing to do. And God bless him, he got a job at WHO, and he did that, changed that in 3 years. And if you know WHO, which I think a global health department like this probably knows a lot more about it than me, that's nearly miraculous. They're not usually on the front end of the curve on things. It's a legislative organization, so you've got to trade votes, and make deals with people in order to get something passed through that assembly. So he took a full-time job there and changed policy. And I said, in Malawi, we want to put this in operation with the lady with the green dress. We don't want any research nurses around her. And what is she going to get for recovery? Because we want to see how robust this kind of intervention is in terms of getting rid of the research element. And then we're going to need a lot more of this food. Okay, so we worked with 25 centers, 12,000 children. Now, bear in mind, these children with severe acute malnutrition are looking at a 50% chance of dying in the next 3 months if they're not treated. So we're talking about a condition that's not benign, it's not transient, it's not age, they're just going to go away. A really dangerous spot to be in if you're a kid, and 90% recovery. 90% recovery of those 12,000 children. And only one of the 25 centers were not able to administer this program in a coherent manner. So operationally robust, policies getting changed, and then we go to what do we need to do about this food. And actually, Heather is standing in the very place with the lady with the green dress. And you see the nature of that program was dramatic. Those kids look a lot more vibrant. There's a lot more of them getting help. They're only coming every 2 weeks for a clinic visit rather than staying there and drinking this milk all the time. People are willing to access care much earlier than they were, because at the last resort of going to the hospital. And this picture is meant to tell you don't need a hospital. You don't need a clinic. You just need a table under a tree. Because what do you need to do? You need to check them for edema. You need to measure their weight and length. And they're getting a foodstuff, which not a controlled substance that you need to be a doctor to prescribe. So I went to food companies at this time, and I told them about this. And I said, I'll help you make it. I'll show you how to do it, because we had been making it for those 3 years. Our team had been making it. And for those 12,000 kids, we actually, something you would never see in the U.S., and will make the occupational health people in the world cringe. But a company that made peanut butter said, sure, you can use our equipment. Just send your staff in on second shift, and you'll be responsible for what happens. So anyway, I went around to food companies because I knew we were going to need a lot more of this food. And I got the same kind of response I got from the medical community. What a bad idea. Haven't you heard about blended flours? We're absolutely not touching a product like this. Whether they be very big companies like Nestle or maybe local African processed food companies. So, being the engineer, I said, fine, we'll start a not-for-profit to make this food. And that's what Project Peanut Butter is. It's an associated not-for-profit. My university doesn't want to own big things and take that liability, so we started a not-for-profit to do that. You can see right now we are at very active programs in Malawi, Sierra Leone, and northern Ghana, and we have factories in those places. And this place where we make the food needs to meet the same standards that European infant formula manufacturers do. So there's a quality system in place and extremely low levels of salmonella and all kinds of hazard, HACCP, hazard analysis, critical control point things in place. So I've learned something new. Another sort of mantra I've had is I never really want to be limited by my own knowledge at this point. So if I'm still not that old, I can learn new things. So if I need to learn about how to make food processing and how in the real, I can do that. And we did that in 2004 and 5. So this picture I'm really proud of. This is a picture that's in a book, from a book every year that I'm sure you're familiar with, State of the World's Children. And the color of the country has to do with under 5 death rate. And red is bad and like over 15% or over 12%. And orange is like sort of 6 to 12%, and I think green is less than that. And Malawi's green. And nothing has changed about Malawi from the first pictures you saw in this room. It's not undergoing urbanization in Malawi. So why is Malawi green? Because they've gone after the biggest child health problem in I wouldn't say a systematic way, in sort of a system organized from the top, but in a comprehensive way, trying to reach out something that was very effective. So this story here is about developing something that's very effective and then trying to put it into operation, getting partners. In 2007, the UN agencies endorsed home-based therapy as the best way to treat severe malnutrition. In 2009, UNICEF got all about it and started providing this kind of food and treatment protocols, and there's been a lot of other agencies that have supported that too. And then working with local village health aides, okay? We don't want to get into a system where we're having wedded ourselves to a health manpower poor medical delivery system, because this isn't dangerous. You and I can open it up today and eat lots of it. Nothing will happen to us, unlike ART or something. So I'm most proud to see that Malawi has sort of come to a place where their child death rate is just dramatically lower. So now I want to talk about something that we're currently working on that's a little more of a conundrum. That's kind of a mature story, a story that has an end and a solution. That's chronic malnutrition, which is stunting. So we all know that those are all over the Sustainable Development Goals. We're not going to achieve those unless we do something a lot about stunting. Stunting, as you know, is shortness measured in stature. It contributes to about 21% of the DALYs for children. I think I have some more about it here. In rural Africa, it affects about half of the kids, and they are about 22% less likely to attend secondary school. Their income will be 22% less. They're less likely to attend secondary school. Their life expectancy is 17% less, and this costs them about 8 IQ points. Okay. The term chronic malnutrition is old and may not exactly be what you think. I mean, if you think of malnutrition as something that's caused by not getting the right kind of nutrients, then I think chronic malnutrition is probably something else. It's poor growth and development is what stunting really is. And it's been incredibly refractory to things that people have tried so far right now. So what causes stunting? The way I think about this is it's like a 3-legged stool, and you have to have each leg in place in some solid way in order to get normal growth and development. And if there's something really wrong with any one of those legs, you're not going to get kids growing with normal growth and development. And what they need is an adequate nutrient intake. So we still live in a world that mass is conserved, and we can't just make something from nothing, okay? The bacteria in your gut will not do magic like that. You need to have what we call good gut health. Okay, and we'll talk a little bit about what gut health is. But so not only just the right kind of things going in, but the gut needs to be able to receive that and absorb it, as well as not remain in a chronic inflammatory state forever. And you have to be lucky, in a sense, to not have an excess of acute infections. So we're all going to get acute infections. Every kid in the world is going to get acute infections. But just like with malnutrition, severe malnutrition, those kids who are unfortunate who get 9 episodes instead of maybe say the average is 6, they are going to be less likely to grow and develop, because when you're inflamed and fighting infection, you're not growing. So these are like mutually exclusive conditions. Okay, so this is gut health. Okay, this is a histology picture. The one on your left is normal gut. You can see the gut is not a tube. It's got a lot of fingers that all interdigitate. It's got some thick mucus protective layer, and this large surface area is meant for sucking up nutrients, but also not having a lot of contact with microbes. The gut over here on the right looks like a gut that has, might be prevalent. We don't know for sure. I'll show you a map, but a lot, I would say half roughly or something, of kids in sub-Saharan Africa, or maybe 2/3 of rural kids in sub-Saharan Africa, have a gut like this. Remarkably reduced surface area, nutrient absorption is decreased. It's a chronically inflamed state. It's a chronic infection, if you will, so they're not able to grow. That's one whole leg of the stool. So no matter what you're doing with the other two, if you don't have good gut health, you're not growing, and that's why I think stunting is refractory so far. And we've had tremendous projects trying to attack the other two, or bolster the other two legs of that stool in terms of like food. There's a big project funded by Gates about a decade ago or so called Islands that I had something to do with, where some children were actually, from the time mothers were identified as pregnant till they were 18 months of age, got a perfect diet. I mean, everything the WHO said they should get was supplied to them, and they didn't grow 1 millimeter taller. And this was in Ghana, Burkina, and Malawi. And on the other hand, if we think about reducing the number of infections, I mean, if you go to, and you guys, this might be your home territory, so I'm going to, forgive me if I step on anyone's toes, but when insecticide-treated bed nets came into being in western Kenya around Eldoret, I mean, they were essentially enforced house to house by police or something, and transmission rates went down by logs, and children grew a 20th of a standard deviation more for that benefit. So it doesn't mean that you don't need to have less exposure to infections or an adequate diet. It does mean that when those two pillars are in place, you still need something else in order to grow. Here's a map that shows you poor gut health, and blue means worse gut health, and it's obviously made with intense speculation on people's parts, because we don't have lots of direct measures of this. And to drill down a little bit more, I'm not sure in this audience how many people want to know this kind of thing, but at this point in time, how do we assess whether you have good gut health? Because these children don't have diarrhea, they don't tell you their gut hurts, there's nothing about examining them that's going to get you to recognize they have poor gut health. So we use a sugar test, and these sugars are not used by the body, they're just simply excreted in the urine. One of them is a big sugar, which would only get into your body by leaking in holes in your gut, and one's a little sugar, which is going to be absorbed directly proportional to the surface area. So if you have less surface area working on your behalf, you're going to have a lower mannitol. And it's given in a standard sort of way. And then this picture here shows you that lower numbers with this lactulose mannitol test are better or more normal. And the bar graph over there on the left is if you have a normal LM test, you're growing. That's linear growth on the y-axis over there. And you have a worse LM test, their subsequent growth in 3 months is going to be less. And you can do things like, see if they're correlated, and they're highly correlated, and you can put them into regression models and show you that LM is something that's very predictive of growth, independent of, say, how much food you have, their diet, the quality of your diet. And interesting that in these kind of models where we have communities that are very closely monitored, probably too closely monitored to be called normal anymore. The days of fever and diarrhea are less important than your diet or your gut health in terms of predicting your growth. Okay, so this condition of poor gut health is also called EED, environmental enteric dysfunction. We have developed some tests. This is, like I said, I'm the kind of person who when the problem is roadblocking us, then I want to go solve that problem. So when I needed to get a lot of food and I couldn't get companies to make it, then I said, we'll have to start an NGO to make food. And when we needed a different, easier to use test than the sugar test to figure out who's got gut health, I started a lab and we started looking for host transcripts, mRNA and stool. And so that's what the next few slides are about. So this is just showing you that stool's non-invasive. The graph over there shows you that this measurement is not affected by, sort of rapidly taking the stool and freezing it in liquid nitrogen. I saw a presentation yesterday where people were proud that they could do that in 7 minutes. The different colored dots are how long you leave the stool out at ambient temperature, up for 24 hours, and you don't really get a very different answer with that. And also, you can imagine, if something's really common, it has many causes, okay? You shouldn't be lured into this idea that it's a really big problem, it's really common, we just need the thing, the bullet, I mean, this gut inflammation probably has 20 or 30 important causes. With looking at RNAs, you can look at a variety of different host responses. And so we developed a method. People don't routinely ever measure host transcripts in stools, so we had to develop a method to isolate these that was highly, gave you the sensitivity and specificity that you needed. And we started using a microarray for the whole host transcriptome. And I guess what I want you to see about this is if you look, where am I? Anyway, if you look at the table below and you see that it says function associated with EED, you'll see that these particular genes and transcripts are talking about a whole breadth of microbial responses. We've got funguses, we've got parasites, we've got bacteria. Yes, we have a lot more viruses than people would think, and it does lean toward the virus thing. But so this is not a problem of an infection. This is not a helicobacter or something like that. This is a problem of exposure to too many microbes. And this is you can take these whole transcriptomes and sort of align them with biological pathways to see which ones are statistically upregulated and downregulated. And this is like things on this side, these canonical pathways. 2 of them are about cell adhesion. So the cells in the gut aren't forming tight barriers like they should. And the other ones are all about responding to different microbes. Okay? So this biomarker is a panel. So we can put as many as you want to do in your PCR reaction. You have to use not standard qPCR. We need to use something that is called digital drop PCR because we're dealing with very low copy numbers. Stool is a sea of nucleic acids, and almost all of them are from bacteria, and lots of them are from ribosomes. And I just want this little 1% to look at to tell me whether this child's what might be going on with this EED. So this cartoon and the histology tries to explain to you what good gut health is and what's going on. So the pictures on the left are normal, the long finger-like villi with a very solid integrity on the border. This is all protected by a mucus layer, okay? That's like your skin. It's the most important part of the gut protection in immunology is not T cells and B cells and da-da-da. It's about a physical barrier, which is the mucus. something's wrong with the mucus. On those transcripts of the etiology of ED, you'll see that these mucins are underexpressed. You'll see, it's consistent with why would so many different things be irritating the gut. So something's wrong with that barrier layer. It's causing the exposure of lots of microbes to the gut surface. There are some of them puncture holes, if you will. There's a whole diverse set of immunologic responses that involve T cells and B cells and natural killer cells. So what is poor gut health? If you look down that list on the right, it's a compromised mucus layer which allows invasion of tissues of microbes, which breaks the junctions, opens the junctions between the cells, and there's then a recruitment of a multitude of immunologically active cells and molecules, and then I'm suspicious about viruses play a lot more of this role than other kinds of microbes, which sets up chronic inflammation. Okay, so now we're chronically fighting an infection all the time. Some of the cells are dying, and we're not growing. Okay, so this is a current problem, and this shows you a couple more things of sort of higher technology. From all that, we developed a list of 16 transcripts of interest, and since none of these things form a test, and this is the 21st century, we're going to do some machine-based learning, some random forest modeling of a small panel, and if we use test for 4 of these things, we can identify children with good gut health or very bad gut health with about 84% specificity or sensitivity. The specificity will be similar as well. So, if we factor in clinical risk factors, the sensitivity can go up to 91%. So these 6 risk factors are associated with bad gut health. In younger children, if your weight for height is less than the mean, you don't have a clean water source, you don't have a pit latrine in your home, because you might wonder, what 1-year-olds are using a pit latrine anyway, sort of thing. The child sleeps with domesticated animals, or they've had diarrhea in the last 7 days. So if you have 5 or 6 of these, you're very unlikely to have good gut health at any given time. So that is a problem of chronic malnutrition. I've done about 6 or 8 trials of interventions. So this is different than the other trial where we're identifying very vulnerable children who have a very distinct syndrome. You can always tell whether somebody has acute malnutrition or not by doing a few simple things. They either meet those criteria or they don't, sort of thing. Here, we don't, we have risk factors. We could do a test on your stool, this kind of stuff. But we see that it's something affecting a lot more people. So when we want to do something to make this better, it's going to have to be something safe and cheap. Okay, nobody's going to go for acute malnutrition. The treatment cost is probably $75 a kid, and agencies around the world love to pay for that because it's taking somebody with a 50% chance of dying in the next 3 months and giving them a 90% chance of recovery in the next 6 weeks. Whereas with the stuff with gut health, it's going to be distributed out with lots and lots of people, and it's not. We can't use it. So my pitch would be against, say, drug interventions. This kind of thing. I mean, we have people that are treated for inflammation of their gut in this country with Crohn's disease or ulcerative colitis, and maybe even some people in the room might have that problem, and those are very expensive drug regimens and a chronic illness. This is not what we're going to get to make the EED go away. The kind of trials I've tried, some of them have been A, designed to inform me about what's causing EED, and B, designed because they could be rolled out in a widespread way. And the ones that we haven't worked so well are non-absorbable antibiotics and probiotics. These haven't had much. Makes sense to me in the sense that this is happening in a different place in the gut than where all the bacteria are. Bacteria tend to be in the bottom of your gut, in the colon, your ileum, and this is happening way up where the nutrient absorption is. Trials that worked a little bit were deworming. or multiple micronutrient supplementation. Okay, trials that are ongoing, we're using with legumes. Legumes have certain kinds of attractive oligosaccharides associated with good gut health, and common beans and cowpeas are the two legumes we're using. Introducing them as a complementary food supplement. So we've got kids under surveillance right now for a year, starting at 6 months or starting at 12 months. So see if a food-based intervention that would be, people can grow beans, people do grow beans, it's part of many diets in sub-Saharan Africa. And we'll be doing undoubtedly some more trials, I think. I mean, what's attractive to me in those these trials would be some kind of dietary intervention which would strengthen the mucus barrier kind of thing. Okay, so an active problem, a huge problem, no solution yet, but actively working on it. And then just to finish up, I want to talk about something fairly futuristic. I mean, can we feed 9 billion people in this world? I think the key has to do with agriculture. There's a notion that's come up in the last 10 years. It's not food security. It is food security, but in addition it should be nutrition security. So your diet should provide all the nutrients that you need, as well as just being plenty of food. And things that have worked very well in agriculture involve adding inputs to the land, fertilizing water and nutrients, irrigating. One thing that hasn't worked well at all, which is where people say, well, what do you need to get in this diet? Let's go and counsel people and encourage them to grow the right things on their smallholder farmers to see if that changes their health. And usually these are to stereotype somebody here, probably offend somebody even, because it'll identify somebody. But PhD graduates from Michigan State driving around in a four-wheeled vehicle, talking to these farmers about dietary diversity, and actually they're completely rejecting this because they're doing something that's already smart. They know food is in tight economy, and the way to get the most calories off of a piece of land is to grow cereals. That's why those are the staple foods of the world: rice, corn, wheat, different tubers. So telling them they believe, and probably rightfully so, things will be worse if they stopped growing some of those and started growing more vegetables. Commercial farming is more efficient, but you have to have something for the rest of the people to do. So if we suddenly said we could make farming in Malawi a lot more efficient, then we need somewhere to employ lots of people. And then biotechnology, which I'll talk a bit about, which I'm excited about. I've done some projects in there. They haven't worked, but we'll talk about it. So biotechnology would be genetic engineering of crops so that you could put more nutrients into the staple foods. Or you could also put pest resistance, or things that are compromising the productivity of the crops. And you wouldn't have to change the crops much from social and culturally accepted reasons. But in our country, the only models we have for that are large agribusinesses like Pioneer and Monsanto, and they have some of their own problems, and so therefore there's kind of a social movement opposing that kind of activity. But I had the fortune to work in a project for almost 10 years funded by the Gates Foundation called BioCassava Plus, and cassava is the first root crop in Africa. It feeds 200 million of the poorest people. It's an absolutely terrible food in terms of its nutrient content, but it has some agronomic properties that caused us to want to try biotechnology to make it better. And that is it's vegetatively propagated, so it's not making seeds. We don't have to worry about where genes are going, because they're not going anywhere in this particular situation. To get a new cassava plant, you cut off a stem from an old one, and you put it in the ground, and it's genetically exactly the same as where it came from. kind of thing. It is not particularly water sensitive. So in a climate changing era, where there's a lot of rain and not a lot of rain, and it doesn't have a planting and harvest time. So in other words, like corn is 12 weeks. You put your corn in, and then 12 weeks it grows, and that's what you get. Whereas cassava will grow faster or slower depending on the amount of nutrients and what's available to it. It could mature in 9 months, it could mature in 15 months. And that's vegetatively propagated. The peel of cassava is chock full of cyanide, which is a toxin. And that means worms and bugs do not want to touch it. So it's inherently pest resistant. So we said, what if we could make cassava a healthier food? And that was our Gates Grand Challenge project. So you see here people doing something to get rid of the cyanide before they eat it, which is very important because it's a neurotoxin. And I remember when I first went to Tanzania, moved there to a rural place there was a wedding. People needed to make a lot of food in a hurry. They didn't process the cassava like they should have, and 128 people were permanently paralyzed below the waist after this affair. So it's not a public health problem in terms of millions, but it was something that we had on our radar screen. So what we said we wanted to do with cassava was improve the protein. It's got the lowest protein energy content, 1% of any staple food in the world. Put more micronutrients into it, make it resistant to a plant virus, which is cutting down on the yields, and get rid of the cyanogenic glycosides. And so the lessons here are just almost personal or personal science observations rather than a story like the first story that I think is a success, then the second story, which I actually believe we will be successful on in the next 5 or so years. The plants are not bacteria. Bacteria can be made, genetically engineered to do anything. I mean, insulin is now made by bacteria. It used to be extracted from animal carcasses. When you put genes into people or plants, usually they just die. It's dysfunctional. So when we're trying to put more protein into cassava, we kind of learned this lesson. The empty box over there shows you it's a staining for protein. So there's no protein in cassava, okay? And we tried 3 strategies. We said, hey, let's introduce a gene with a storage protein, which has got high amino acid quality, and let's see what happens there. And so what happens is the cassava makes that protein at the expense of making other proteins that it really needs, and the net protein isn't any different, but the cassava is much less healthy as a plant. The other strategy we tried was to take the cyanide, which is a form of nitrogen, and let's divert it over to making more protein. When we tried to do that, what we found is the plant won't even grow or germinate. This is just absolutely essential to this plant biology. And then the third strategy we tried, which was successful, was we knew that in sorghum, that if you stack proteins very closely, they won't break down. So a certain 33 amino acid leader sequence will allow them to resist degradation. So these protein granules. So we engineered the plant to make protein granules and increase the protein energy ratio 5-fold in that. And this is showing you some vitamin A work that we tried to do by upregulating. And in the end, the project did not result in massive improvement in people's lives. This stuff is being grown in Nigeria and Uganda now. But to finish right now, I've taken up a lot of your time. Is there enough food in the world to feed for everyone? Certainly, it needs to be a lot of work and investment on technology as well as appropriate technology with agriculture. We have enough food right now. We don't have an economic system that's able to transport it and distribute it in the places it's needed. But we don't have more land because that's what's typically happened in the 20 centuries or however many 40 centuries or whatever that before this is when people needed more agricultural production, they went somewhere else and made more farms. We have to make farms that are more productive here in the 21st century. Now, this isn't the first time we've ever encountered these problems when people, if you start feeling like this is very pessimistic, how could we ever do this? We're just going to create a lot of starvation and suffering in the world. You think about Africa in 1600, it was a hunter-gatherer society, and they were pushing the carrying capacity of the land, because you need to have much more land, even tenfold or 20-fold, to support a hunter-gatherer than you do to support a farmer. And so those bad colonialists came to the coast and took slaves, but they introduced corn, cassava, cereal staples from the New World, which spread across the continent like wildfire, even though the colonialists weren't, and converted Africa to an agrarian society, which is able to support many more people. So it's unexpected. Nobody was intending trying to do that, but it actually turned out to be quite a solution. And then the other solution I would allude to here is the Green Revolution for India in the 1950s. So India was having these famines. I mean, it was the most densely populated place in the world almost. And everyone in the world just said, I mean, what can we expect? It's just going to get worse and worse. There's going to be more and more starvation. But recognizing that the biomass of a plant is usually determined by the amount of carbon dioxide in its environment, and it's limited in that way. So you just can't make plants be bigger and bigger or something. But you can make them have bigger edible parts, like bigger seeds and smaller leaves. And so selecting for varieties like that was a key element of the Green Revolution. And so rice plants that make bigger edible parts were introduced, and India has not had massive starvation. So I just throw those anecdotes out there. Obviously, there's a lot to them. We could talk about each one for an hour, but that there is hopeful things happening. So I think these are important problems. We need to address them in global health. They're likely to have an unexpected sort of solution. That's all.